Welcome to the section D part of our internal assessment 3. Here we'll face the assertion reason questions. These are often considered as the trickiest part of the exam because they require us to understand not just what it is true, but why it is true. We will be analyzing logical statements to determine if a cause and effect reasoning relationship exists, starting with the classical statistical warning that looking how and managing learning rate directly controls the step size in gradient descent to minimize cost. Additionally, we'll discuss the theoretical power of neural networks as universal approximation and the practical foundation of SQL joins in relational database. Let's sharpen our critical thinking skills and evaluate this argument step by step. So, hello and welcome everyone to the section 4 of our internal assessment 3 of data science. Here, let's see, we have a session reasoning questions. First, we'll answer the question. Next up, we'll have the explanation of the answer. So, question 30, we have assertion as correlation does not imply causation. And in the reason we have, it measures degree of relationship but must cause effect. So, here the options are both A and R are true, and R is correct explanation of A. B is both A and R are true, but R is not correct explanation of A. C is A is true, but R is false. And option fourth is both A and R are false. So correct option is option A. Both A and R are true, and R is the correct explanation of A. Correlation only shows us how strongly two values move together, not whether one causes the other. So the reason correctly explains that the correlation is a statistical relationship, not a causal mechanism. So because of this, the conclusion about cause must come from controlled experiments or deeper analysis. Hence, both statements are correct and well aligned with assertion and reasoning. So, huh? So next up, we have question 31. Uh, In this, we have assertion as gradient descents uses learning rate for step size, and in the reason we have it minimizes cost in linear regression. So we have the options as similar in the previous question. So we are not reading out the options. So here the correct option is option A. Both A and R are true, and R is correct explanation of A. The learning rate determines how big each update step is while moving towards the minimum of the cost function. So gradient descent is indeed used to minimize the cost function in linear regression. Since adjusting the learning rate directly controls the minimization process, the reason properly explains the assertion. Both the statements support each other. Question 32. Assertion says that neural networks are universal approximators, and the reason says that they can approximate any complex function with enough layers. So the correct option for this is option A. Both A and R are true, and R is correct explanation of A. The universal approximation theorem states that a neural network with sufficient complexity can represent any continuous function. The reason correctly describes why it is true. Deeper or wider networks can model nonlinear patterns. This flexibility makes neural network powerful for complex tasks. Thus, both the assertion and reason are valid and well aligned with each other. Now, coming upon the final question of our section 4, which says assertion as in SQL, join combines row based on related columns, whereas the reason says that it handles data from multiple tables. So correct answer for this is both A and R are true, and R is correct explanation of A. A join is specifically designed to match rows from different tables using a common key or a defined relationship. So this allows integrating information from multiple sources into a single output. The reason accurately describes why joins are used in relational databases. Therefore, both statements are correct, and the reason justifies the assertion. So let's move to the section 5 of our internal assessment 3. which is final section of the third internal assessment. Let's begin with question 34, which is arrange the steps in K4 CV in correct order. The order mentioned here is divide data into K folds, train on K minus 1, validate on 1, repeat K times, and average errors. The correct answer for this is option A, J, K, L, and M. So let's see what we do in K4 CV. So in K4 cross validation, we first split the data sets into K equal folds. Then we train on K minus 1 folds and validate on the remaining one. So this process is repeated until each fold has served as validation. So let's take an example for, let's say our data sets is has five subsections. So first time the data will be we split the data into, let's say, in the five subparts. So first in the first iteration, data will be trained on the four parts of the starting one and tested on the remaining. And in each iteration, this process will continue. And finally, all errors are averaged to get a stable performance estimate. Question 35. Arrange the gradient descent algorithm in correct order, which is compute a gradient, update parameters, choose learning date, repeat until the convergence. So correct answer for question 35 is option A, L, J, K, and M. So gradient descent begins by selecting suitable learning rate. Next, the gradient of cost function is computed. Parameters are then updated in opposite direction of the gradient, and this loop repeats until the algorithm covers to an optional point. Coming upon question 36, arrange the k-mean steps in correct order. Assign the closest centroid, random initial assignment, compute new centroids, and iterate until no change. So correct answer for is option B, K, J, L, and M. So k-mean starts by randomly assigning initial centroid positions. Each position is then assigned to the closest centroid. The centroids are calculated based on these assignments which we just made, and this cycle continues until cluster assignment stops changing. This means two obtained continuous values are nearly same. Question 37. Arrange the map reduce process in the correct order. The orders mentioned here are map, which is process data to key value, shuffle and sort, reduce, which means aggregate, and the output reduce. So the correct option for question 37 is option A, J, K, L, and M. So let's see how the MapReduce works. So in MapReduce, the mapping phase processes input in the key value pairs. Then these pairs are then shuffled and sorted to similar keys are grouped. The reduce step aggregates value for each key, and finally the aggregated results are written as the output. Now coming upon question 38, arrange the neural network training in the correct order. The mentioned order is forward propagation, compute loss, back propagation, and update weights. So correct option is option A, J, K, L, and M. So training begins with the forward propagation to generate predictions. The loss is then computed by comparing predictions to the two values which we have already been known. Backpropagation calculates gradients for each parameters, and in the end, weights are updated according to improve the data of our data sets. Coming upon question 39, arrange the PCA steps in correct order. The steps mentioned are standardized data, compute covariation, find EG vectors, and fourth one is project data. Correct option is option A, which is J, K, L, and M. So PCA basically starts with standardizing features to remote scale differences. Covariance matrix is then computed to capture covariance relationships. Then LE vectors are extracted to identify principal directions, and in the end, the data is projected into the new components. Question 40, which will sum apart the internal assessment tree. Arrange the head of components in data flow in correct order. The mentioned order is HDFS storage, yarn scheduling, map reduce processing, and output to HDFS. The correct option is option A, which is JKLNM. So Hadoop workflow store input data first in HDFS. Yarn then schedules and allocates resources to the mentioned task. The MapReduce processes the distributed data, and in the final processed output is written back to HDFS. So we have successfully covered all the subsections, which are section 1 to section 5 of our third internal assessment. Now, in the next step, we'll see the final exam question paper and we'll cover it the same way which we have done, covering it section wise or any of the preferred way. Till then, keep learning. And that wraps up section E of our complete review of the internal assessment tree of data science. We have successfully ordered the chaotic world of algorithm, establishing that the K4 cross-validation, you must divide the data before you can train and average the errors. We have also traced the mathematical journey of PCA from standardized data to protecting it into envelopes and confirm that the gradient descends. We compute the gradient before updating the parameter. Understanding these flows is typical for debugging and implementing models in the real world. I hope these explanations have clarified the entire syllabus for your exams. So trust your preparation, focus on the logic, and you'll surely do great. Good luck.